Hi everyone, let's work together on adding and subtracting some rational expressions with different binomial factors. We'll start off with example 2a. We'll have to write the final answer in simplest form, don't forget, and state the restrictions on the variable. So in the first example here, we have x over 6x plus 6 plus 5 over 4x minus 12. So we have addition of two rational expressions, and as you can see, their denominators are different. Just like with numbers, in order to add fractions or rational expressions in this case, we need the denominators to be the same. So since they're not the same, we'll make the denominators equal to the lowest common denominator. And for this, we'll start off by factoring each denominator. So in our case, we'll have x divided by 6 over x plus 6 will factor into 6 times x plus 1. And 4x minus 12 will factor into 4 times x minus 3. Now we can state the lowest common denominator, and we'll start off with the monomial factors. So these are numerical. So lowest common multiple of numbers 6 and 4 will be part of the or a factor of the lowest common denominator. In our case, we have 12. That's because 12 is divisible by 6. 12 divided by 6 is 2, so it divides evenly. And 12 divided by 4 is 3, and that is the smallest number that can divide evenly into 6 and 4. So 12 will be one of the factors. Now, for the rest of the lowest common denominator, we focus on the binomial factors and check to see if they're same or different. So in this case, they're obviously different. And we are going to list both of them as part of the lowest common denominator. So we'll write x plus 1, x minus 3. So while we're at it, we are going to state restrictions. Remember that this will be the new denominator of our final expression, and this cannot be equal to 0 because if it becomes 0, the expression will be undefined or make no sense. So we're going to say that number 12 is already numerical. We know the exact value of it, but x plus 1 and x minus 3 has a variable, so an unknown number that can change. So we have to determine what values of this variable, term would make the factors equal to 0. So we're going to have to state the restrictions as x plus 1 different than 0, and you solve this just like you normally solve a regular equation, but it doesn't have an equal sign but different than sign, so you transfer 1 to the other side, negative 1, and then x minus 3 different than 0, which means that x has to be different than 3. So in the next step, we're going to make the denominators of this expression the same as the lowest common. And for this, I like to rewrite the exact same expression, but a little bit further apart from each other. And what I mean by that is that we need to leave a little bit of room for the rest of the denominator in each rational expression. So if you have 6 and you want to make it a 12th, it means that you need to multiply this denominator by 2. So that means that we're multiplying both numerator and denominator by 2 over 2. And that is because when you make the denominator, bigger, in this case, then you have to change the numerator to maintain the value of the expression, because 2 over 2 would be equal to 1, and that keeps the value of the expression the same. Now, in the same way, we are going to work with adding the other factor here, so x minus 3, and that means that we'll multiply both the denominator and numerator by x minus 3. Similarly, we work with the next rational expression. Here we have 4. We want to make it a 12th. That means you multiply by 3 over 3. And we have x minus 3. We need to introduce the x plus 1 as a factor here. So we'll multiply by x plus 1 numerator and denominator. So in the next step, we're going to start simplifying our numerators. And here we have 2 times x, so just write them in proper form, 2x, x minus 3. over the lowest common denominator, which now is 12 x plus 1, x minus 3. So 6 times 2, 12, and then the other two factors. And similarly here, we multiply 5 and 3, and that would be 15 times x plus 1, and then denominator is 12x plus 1, x minus 3. Now that the denominators are the same, we can go ahead and add these two rational expressions. Remember, when we add, we keep the denominators the same, and we simply add the numerators. So we'll start off by expanding 2x times x squared, 2x times negative 3, negative 6x. Now 15 times x is 15x, and 15 times 1 is 15. Lowest common denominator, entire expression as is, would be 12x plus 1, x minus 3. Now, one last step, we'll simplify the numerator if possible, and what we can do here is add these two like terms, and that will give us 2x squared, negative 6 and 15 add to 9 plus 15, and in the denominator we're going to write the same lowest common denominator, 12x minus 3, and then x plus 1. And we're going to state the restrictions that x has to be different than negative 1 and different than 3. And obviously, we're going to have the x plus 1 in here. I'm trying to follow the undo button, and that's why it's kind of missing in here. So I'm going to, I don't know why that happened. So this would be the final statement, and that's how we add and subtract rational expressions with different denominators. We're going to give it another try in our next example when we are looking into adding and subtracting in the same time, not just two but three rational expressions. So let's get to work. So as in the previous question, what we're going to try to do is examine the question. So inspect what you have. And our focus will be on the denominators, which are all different. So next, we will have to factor denominators because that helps us find the lowest common. And what we're going to have in this case is three different denominators. None of them are factorable. So we can jump to finding the lowest common denominator, which in our case will be made of this factor x, and then x plus 4, and then 2x minus 1. Now, since we're at it, again, we're going to state the restrictions. We're going to say x cannot equal 0 because it is a factor, and multiplication by 0, by this factor of 0, will make the entire denominator 0. Also, x plus 4 has to be different than 0, which means x has to be different than negative 4, and 2x minus 1 different than 0, which means x has to be different than 1/2. So our restrictions are x different than 0, different than negative 4, and different than 1/2. Now let's get to work and try to make all these denominators same as the lowest common. Again, I'm going to rewrite this same expression in the same way, but a little bit further apart from each other because I want to make room for my new denominators, creating the new denominators. So here we have just x, so we're missing x plus 4 and 2x minus 1. Again, we're multiplying both numerator and denominator by x plus 4, both numerator and denominator by 2x minus 1, and notice how lowest common now is the same as the denominator in the expression. Vice versa, here we have x plus 4, so we have this, so we are missing x and 2x minus 1, so we're multiplying by x over x and 2x minus 1 over 2x minus 1. Lastly, we have 5x over 2x minus 1, so in this case we have 2x minus 1, we're missing x plus 4 and x, so we're multiplying both numerator and denominator by x and by x plus 4. So as you can see now, all our denominators seem to be the same, and what we're going to do is start simplifying these numerators. Now when you simplify these numerators, notice here we have two binomials and a monomial. So it's multiplication of three things. In multiplication, the order doesn't matter, but when you have a combination or a mixture of monomials and binomials, it's better to multiply the binomials first, because multiplication by a monomial is easier afterwards. Whereas if you start with a monomial, you're going to make this binomial bigger and then multiply it with something also big. So we're going to start off with the first one, x plus 4 times 2x minus 1. So we're going to keep the 5 there. Will become 2x squared. And then we have x times negative x and 4 times 8x. So negative x plus 8x will make 7. 8 minus 1, right? And then 4 times negative 1 makes negative 4. Close brackets and write the lowest common denominator. Next, we'll have these two binomials. As you can see, they make difference of squares, and we have the monomial x. So always start with the monomial, so x, multiplied by these two will multiply to 4x squared minus 1. Simply follow the formula a plus b, a minus b, which multiplies to a squared minus b squared. And that would be under the lowest common denominator. And lastly, we have monomial. Monomial multiplied together, they will make negative 5x minus 5x squared times the binomial x squared plus 4 over the lowest common denominator. Now that the denominators are the same, we can go ahead and simplify the rational expressions. So bring them in the same rational expression, and we'll start off with expanding this numerator, 10x squared plus 14x, and then minus 20. And next we'll have the product x times 4x squared 4x cubed minus x, and then we have minus 5x cubed. Now remember this negative sign in here, we'll multiply this x, and then plus 20x minus 20x squared. Now remember this sign will apply to both multiplications, and that's the reason why we get two negative terms in the expansion, and everything will be under x plus 4, and then 2x minus 1. Now next we are going to simplify the numerator. So let's collect like terms first, and here we see that we have like terms 4x cubed, negative 5x cubed, that will give us negative x cubed. Now the x squared terms are negative 20 and positive 10. That makes negative 10x squared. 14x and minus x, this is a typo by the way, and 14 minus 1 will make 13x, and the only constant term is minus 20, and divided by the lowest common denominator. So this would be the most simplified form. You don't know how to factor polynomials of third degree yet, so you're going to learn this next year, and we're going to leave this expression the way it is. You can try only factoring by grouping, but as you can see, and this prime number kind of helps us determine that, make that decision quickly. This isn't factorable by grouping, and that would be our final answer, and the restrictions at the end listed in order from lowest to highest, so negative 4, 0, and 1, 2 are restrictions to the expression, and this would be the final answer. Okay, now in the next example we have trinomial denominators, and we will look into trinomial denominators in the next video. Thank you for learning with me, and bye for now.